Hi, friends. Welcome back. Like what we discussed in the last session, we are going to continue on that aspect here. In the last session, I talked about data engineer role. Basically, it's as a plumbing role, right? Where we try to connect different systems to ensure that the data is moving from one system to another system like flowing water. So, when we are trying to design it, we basically have to ensure that the data is moving from one source or basically one point, which is the source, to the destination. This is called as data architecture designing. Let's talk about this. So, as part of the fundamental concepts, the first step is we need to design and basically come up with a plan on how the entire data design, data flow design has to be there. This includes the tools and technology that we are going to adopt as part of the organization standards. And when I talk about standards, every tool and every organization or every technology that for that matter will have certain predefined standards, and we ensure that the entire data pipeline architecture that we're designing is maintained by following certain standards, and this has to be defined properly, right? So processing these entire operations has to be properly defined. Now, when we talk about data architectures, it can be broadly categorized into these five layers. It all begins with ingestion and collection layer, where we try to capture the data from different sources. We pull the data or ingest the data. Then we do pre-processing layer. This is where you try to clean your data and gather or streamline or standardize the entire data that is coming from different sources. Then we store the data in a storing layer. When working with storing layer, obviously we have to be very futuristic because um, data eventually grows, so we have to think about future and the design has to be scalable. Then comes the query layer, where the actual analytical um, solutions are implemented, and we ask certain questions in this layer, which basically is nothing but the analytics. The results that we are getting from this layer has to be represented in an easy and convenient manner for the end users, who are the business users. So in visualization layer, we try to come up with graphical representations or stories using nicely designed dashboards. That's where the value to the data can be appreciated. Along with these five layers, of course, we also have to ensure that the security and monitoring is implemented, typically for all the layers, because data cannot be leaked, and data cannot be accessed by everyone. So role-based authentication or access controls should be there. Authentication should be there. Even if in case data is accessed by unauthorized people, data cannot be or should not be easily understood. So we also do encryption for context sensitive data. And we have to keep a close watch on the entire process. Now, in the industry, when we talk about data architectures, there are different designs completely customized to the business requirements are there. But if you summarize all of that and look at the best practices, we see Lambda architecture is one such architecture which is very widely used. And the Lambda architecture is really appreciated because of its design, which includes three different layers: batch layer, speed layer, and serving layer. If you imagine an organization like Amazon, Amazon has all the transactions stored in a centralized database, right? Let's call that as master database. All the transactions that you as an individual performed till now is history. So that can be accessed from the batch layer, historical data typically. But let's say you logged into Amazon website for doing some transaction, purchasing some product. So Amazon has web analytics. It captures every moment of the user on their website. For example, when did you log in? What kind of category, what kind of products and subcategory of those products you are trying to browse? How much time you spent on each product? Which section of the page you are spending more time on? And from here, where you are navigating. So all this real time transactional data is also captured in speed layer. Now, if Amazon has to come up with some kind of solution for business development, for example, if it has to ensure that the transaction goes through, some revenue is generated, then looking at the historical data and the current behavior, the real time data, it can develop a solution like a recommendation, which probably pops up completely customized discount coupon for you. It can say that only for you this discount coupon, etc. So these kind of actions will motivate the customer to make the investment, purchase the product, right? And we also have serving layer, where any query that we basically give can be processed and you can see the result in the serving layer, right? So this is basically the Lambda architecture, because it's called as Lambda architecture because of the design of Lambda. This is how we write Lambda. And if you see here, three layers are there. Let's call this as a batch layer. Let's call this speed layer. And this is serving layer. You can basically allocate batch layer here, speed layer there. Ultimately, three layers are there. So the design is in such a way, right, where it looks like a Lambda symbol, hence the name Lambda architecture. But if you ask me, is this the only best practice that the industry has? Then no. We also have various other architectural designs that are typically used by the industry. One such another example is called as Kappa architecture. Now, in comparison to Lambda, here you have only one layer, and that layer is always your real-time layer, streaming layer. So everything is streaming here. So if you talk about the data source typically is your real-time layer, the live data. But what about the historical data that is there, right? So on the historical data, we basically perform certain, you can say, transformations that are required, so that when you're writing any query as an end user, you get the data in that required transformed format. All right. So you ultimately have storage where the historical data as well as the live data is processed in same typical layer. Okay, you don't have two different layers here. This is called as your Kappa architecture. Everything is real-time analytics, by the way. Remember that. So these are the typical two designs that we have. But again, any customization can happen. Now, coming to a typical pipeline, when we talk about data architecture design, the logic of the architecture is to ensure that we construct a pipeline where data moves from one location to another location. The first location always is the data source where the data is getting generated. And we have a lot of different type of diversified varieties of data sources in the current world. And then we also have the end users who typically consume the data. But for consumption, these are like end results that we do. But for the consumption, we need to have a destination where the data that we are accumulating from different sources is made available. And from source to destination, when we are moving the data, how or what kind of actions we are doing in the transit. That is also typically very, very important step. So data sources, data processing layer, and storage layer, right? So these are the three different entities that are very important for us to understand in a typical data pipeline. And here we also have the data destinations, which typically are categorized into two different varieties, depending on what kind of actions are we designing in our pipeline. The pipelines can be called as ETL pipelines or ELT pipelines. So if you're extracting the data and then making the transformations, standardizing the data which is coming from different sources, and then you're typically loading, then we will use something called as data warehouses. And if you are building ELT pipeline, that is just extract the data and dump the data first, then we use data lakes. And once the data is accumulated here, and in order to consume the data, we do the transformations for consumption. So these are the typical stages of any any data pipeline that we design in modern data engineering pipelines. So that's basically explain data warehouse and data lakes are there. The cost associated to data warehouses is a little higher because we need to ensure that the data is processed first and then stored. So it adds value, right? It adds the computational value to the cost. Whereas data lakes are much more cost effective when compared to data warehouses. But again, it completely depends on what kind of pipelines we are consuming in our business requirements, right? Based on that, we choose between these two. In our next video, we will be starting with data sources, and then we will move on to transmissions and, of course, data lakes, data destinations. So there you go, friends. Hope you have enjoyed the quick overview of the data architecture and how the data pipelines typically are developed. I'll see you around and hope you enjoy this videos. Thank you.